Hi, and welcome to the Computer Chronicles. I'm Stuart Chaffee. There's some very interesting marketing data on new PC purchases, which shows that most PC upgrades for consumers are driven not by the grown-ups in the house, but by the kids who want a more powerful gaming machine. Certainly there is no more demanding application for a computer than today's graphics-intensive games. So today we are going to help you figure out how to put together the ultimate gaming computer. And we're going to start out with graphics. And here to help us do that is Tony Tomasi of NVIDIA. Hi, Tony.
Hi.
All right, so you've got the brand new GeForce 3 graphics card here, and there's a million cards out there. This is new. What is different, better? It's actually a next generation card.
That's exactly right. The GeForce 3 is the latest generation graphics processor from NVIDIA. So this product actually includes a 57 million transistor graphics processor. To put that in perspective, that's more transistors than a Pentium 4 plus a Pentium 3 put together.
Just on the graphics
Just
card.
on the graphics processor,
Okay.
as well as 64 megabytes of 230 megahertz DDR memory.
But what's key about this is it's programmable.
That's exactly right. For the first time, the graphics processor is as programmable as the CPU. We have an instruction set. Just like the Intel processors have an instruction set that you can program Microsoft Word or Windows with, we now have an instruction set that game programmers can program to create special effects on our processor.
So that means a game developer is not stuck saying, oh, I can only do what the graphics card will let me do. You can make the graphics card do whatever you want it to do.
That's exactly right. So for the first time, really, in real time, game developers can create essentially special effects.
Yeah.
So what used to be the domain just of movies and special effects there, which are render farms and would take hours per frame, we render those same special effects in real time at 60 frames per second.
This is all about what's on the screen. So let's get to the computer here, and I want you to show me a couple examples. First of all, in a game, I mean, you're concerned about the surfaces of things, the texture, the animation. Show us an example. You have a great example, I think, of a chameleon there.
Right. So we came up with this idea of the chameleon to really show off the nature that because it's programmable, it can change the way it looks. And so interactively, we can actually demonstrate programmability with this chameleon here. So it's completely real time. I can look at it from any camera angle, any way that I'd want. It's actually being driven.
So this is all being generated and driven right now in real time.
That's exactly right. All this code
responding to your direction.
Is running on the graphics processor in real time.
Okay. So you've wireframed it, for example?
The first thing, of course, is that the chameleon is built from geometry or wireframe. The animation of this chameleon, how he moves and walks and the skin bends over him, is done with a program. We call that a vertex shader. That's a piece of code that runs on our graphics processor that drives the way he animates. In addition to that, of course, we have the way that he looks. And so we have a variety of what we call pixel shaders to generate special effects that are on the surface of this creature. And so interactively, we can create essentially the Predator look, where he's actually semi-transparent. He actually refracts the ambient light around him, and yet still reflects it, or bends it into the environment.
And again, to be clear, this is no cutscene here. I mean, this is you are running this.
That's right. If you look at my hand and you look at the mouse as I move it around, it's completely interactive.
Yeah.
We can play with this as we see fit. And if you look at, well, this is actually our Invisible Man shader to kind of give you an idea what the skeletal system and the vein system look like. We'll go ahead and let the chameleon continue walking here. We'll talk about some of the shaders. So as we get close, we'll go ahead and zoom in on the surface of this guy. And if you look, just say on the joints of his arm there, the bumps are correct. The way the specular highlights move across the bumps as he animates are all completely correct.
All right. Now, I want you to go to the next demonstration. Another thing in a game is the landscape, the background, the environment. They're often sort of clunky and dull, and they don't really get you into the game emotionally. And you have the ability now to actually generate real-time landscapes too, right?
That's exactly right. Because the processor is programmable, we can actually program the processor to procedurally generate a world. So the advantage here is that where previously worlds would have an end. You could get to the end of the texture or the end of the geometry, and that was it.
So again, this is a real-time generation of this landscape.
Right. If you notice the mouse as I pan it towards the edge of the screen, that's the direction that I fly, and I'm flying around the world. I can get close to the landscape. I can fly up in the air. The other nice thing about this, the world is completely generated, but we've got so much graphics processing power that we can actually have a little bit of fun. So wherever I click on the screen, we have a meteor come flying down, and the meteor does some interesting things. As he clicks and lands, you notice there's that ripple, that shock wave. We do that with a vertex shader. It's actually taking the geometry underneath and deforming it.
And again, you're running this right now. It's not just happening.
That's
the last thing I want you to show us is the hardest thing in a game is the human face, right?
That's exactly right.
There's so much subtlety in the different expressions. Most games, the faces are pretty boring. You never get to know them, right? You have a demonstration here, which is just incredible in what you can do with this card.
Yes, we wanted to solve the problem, or at least attack the problem of creating some emotional conveyance in a character. Today's game characters are kind of blockheads. They have flat faces, maybe moving textures, and typically plastic hair.
So what do we have here? Zoltar.
So we've got Zoltar, which is actually kind of modeled after the Zoltar character from Tom Hanks' movie Biggs. He's a fortune teller, and it's a completely interactive face. I can view him in wireframe. Or not.
Yeah, but go back. Let's see the motion around his, when he talks, I mean, you can see the skin stretch.
We'll move into his face a little bit
his
here.
mouth,
Get nice and close, and we'll go ahead and fire up an animation here. And you notice that what we can do is program the graphics processor to deform his actual skin.
Yeah.
We've modeled the skeletal structure and the muscular structure of his face as programs. We download those to our graphics processor, and we can animate him and move him around entirely in real time. So for the first time in real time, you can get human characters.
Wow.
This is something that even the movie industry has really just started trying to tackle, and now we're running it in real time on a graphics processor.
Okay, so it's NVIDIA's GeForce 3, and it'll cost me how much?
About $399.
All right, thanks a lot.